The issue of chemicals in the environment is a story about science, politics, and humanity's relationship with the planet. My name is Chris Hughes, independent scientist, and this is the Chemical Journeys podcast. Join me as we uncover the story of chemicals in the environment through conversations with individuals working in this space. So, let's get started. Hello everyone, and welcome to the Chemical Journeys podcast. Today I'm speaking with Professor Andrew Johnson. Andrew is an environmental research scientist from the UK Centre for Ecology and Hydrology and a visiting professor at Brunel University. Andrew, thanks for joining me.
You're welcome.
I'm really grateful to speak with you today, Andrew, because I'm aware that you're someone who's very interested in trying to understand what is going on out there in the environment with respect to wildlife, and that you're also interested in the decisions we take as a society, particularly with respect to chemicals, and whether these ultimately help us to achieve our aims. So why don't we start with a little bit of background about you, and then perhaps you can tell us a bit about your research interests.
Yes, thanks, Chris. So I've been working in the field of chemicals in the environment for a bit over 30 years now, and my work has probably followed a fairly well-worn path that many in the field will be familiar with, which is related to understanding the fate and behavior of chemicals in the environment, predicting their exposure levels to wildlife, and trying to assess the risks that they might pose. And this rigmarole is sort of underpins a lot of the way we view chemicals and translate to regulation. And so my work started looking at pesticides, looking at endocrine disrupting chemicals, looking at pharmaceuticals and antibiotics, looking at nanoparticles and microplastics, and I dare say if I stay on longer I'll be looking at PFAS too. But it has been a journey that I became increasingly dissatisfied with, and I decided I really needed a quite different approach to understand how best to make progress for wildlife.
And what has it been that's led to you being dissatisfied?
I get, I suppose, a feeling of a bandwagon effect, that a chemical becomes the chemical of the day. There's suddenly a great outpouring of research looking at ecotoxicity and measurements. You then start to see in the literature papers entitled something like "Effects Seen at Environmentally Realistic Concentrations," and off we go. And if you were to take these papers at face value, you would presume that all the wildlife in our rivers are probably dead or dying, and you'd presume that every 3 or 4 years. Now, I suppose the thing that was a big light bulb moment for me was when I worked on endocrine disrupting chemicals in fish. Probably no group of chemicals have received a greater and broader range of experiments and analysis, both from measurements, exposure, but actual effects on fish. And the observation was that there actually were changes happening in male fish associated with, particularly with steroid estrogen exposure. And one's presumption is that that could lead to difficulties in fertility and reproduction. But at the same time, the fish populations appeared healthy. Now, a colleague of mine, John Sumpter, was helping to lead an experiment in which they actually collected fish with differing degrees of endocrine disruption, and they put them in the same tank as males with no endocrine disruption and got them to breed with females. The presumption was that the fish that had the most males that had the most endocrine disruption would be the least likely to father the next generation because of our beliefs on the fertility. that proved not to be the case. And in
Hmm.
fact, they were quite likely to successfully breed.
Hmm.
And I think that the thought at the time was that even with some impairment, fish that lived, let's say, near wastewater effluents often were bigger and stronger than other fish, and they could push other males out the way and breed. So being slightly less fertile wasn't the problem, it was the ability to get to the females. And
Mm.
this made me pause and think and say, well, how much can we take from our laboratory studies if what plays out in nature is quite, in a way, not sort of unpredictable, but not really at all what you might have expected? So then
Mm.
I thought, what are laboratory studies actually telling me? Perhaps they're misleading me into, in effect, over predicting risk. So if you multiply that many times over, you get to the world where we routinely predict quite harmful consequences from chemicals, and yet no one was coming to us to say that fish were dying out in the rivers. So that led me to take a quite different turn in my research, where I moved to focusing really on wildlife at a basic level, that is populations and biodiversity. And then a very different story started to emerge, particularly about the rivers in the UK.
Yes, because of course you've published a paper recently on this, and recently I had a conversation with Todd Gwynn, who pointed this paper out to me and seemed to have some very interesting findings. I don't know if you want to elaborate on that study.
Chris, are you referring to the paper where we used statistics to look at which were the greatest stressors for river
Yes,
invertebrates?
yes.
Yeah, so we managed to get funding about 6 years ago to interrogate long-term historic monitoring data carried out in England, largely carried out by the Environment Agency. Now, what happens is that people like the Environment Agency and their other examples in the regions and in Europe have various regulatory obligations, and one of them is to monitor the diversity of species and their abundance of invertebrates in rivers. They're often called macroinvertebrates because those are simply the ones we catch in nets. Similar data, not quite as large, is collected on benthic diatoms and macrophytes and also fish. So there was this great treasure trove of almost 30 years or plus of data sitting there on wildlife. At the same time, for other reasons, we measured different chemicals in rivers, some more than others. We measure flow, we measure temperature. We also look at the land, we can predict what the landscape is upstream of a monitoring point. We can predict the amount of wastewater in a river. So what we did in this project is we drew all these different threads together into one integrated data set, which allowed us to start asking some very profound scientific questions. Now, traditionally, I suppose it's been sort of assumed that it would be impossible to tease apart which chemical, which physical stressor, which habitat was more important than another. You see, the way we normally do science
Mm.
is we love to go in the lab and do our tests in the lab because we can control all the variables. We take charge of that. Now, in the wild, we don't control the variables. They're all going in different directions. The answer turned out to be fairly sophisticated statistical methods. And ecologists have got these methods and had them for a while. And what you do is you feed in all the variables. So in our case, we had all the data on the invertebrate species richness, the different chemicals, the habitat, the sewage effluent, landscape. It will put these all into the model, and it would start to see which combination and which individual variables were more successful at predicting the biodiversity of the invertebrates. And the way this model works, so the one that worked particularly successfully was called generalized linear mixed effect models. And the way the model works is it takes a sort of selection as perhaps of 5 variables. And imagine you sort of draw a regression between these variables and the biology, in this case the invertebrates. And you get a sort of regression line. And then you take one of your variables away. So imagine we have ammonia, BOD, arable land, wastewater and zinc. And we repeat the analysis by taking one of the variables away, like zinc. And then if we see if the regression is as good as it was before. And the degree to which it performs less well is called deviance. So you've now got, we had about 42 or so variables. We have 60,000 data points and 30 years of data. So you run about 20,000 models. It takes a number of weeks for the computers to chug through this. I was always rather taken by this process because it reminded me rather of Bletchley Park and Decoding Enigma. There were messages there for us if we could decode them. And that's what this statistical method was doing. And essentially the answer was it put metals like zinc and copper at the top as the most influential of all the variables we used. We also had nickel, organic matter and ammonia, but zinc kept on coming at the top as the most influential for overall richness. Or to put it another way, a model without zinc would on average perform less well. So it was an extraordinary moment for me in that almost like the sort of book of life was opening in front of my eyes. And I call this listening to nature. It's as if I'd finally given a voice to wildlife to reply to us and say, look, guys, if you'd only listen to us, this is what influences our biodiversity.
Yeah, I mean, that's fascinating. And yeah, thank you for sharing that paper with me in advance of our conversation. I did read it and it was really, really interesting. I think, excuse me if I paraphrase or get some interpretation wrong, perhaps you can correct me, but it was really interesting to see that the macroinvertebrate biodiversity had been in a process of recovery since the 1980s up till about the mid 2000s, and then it had sort of generally seemed to have leveled off, although some groups of families seem to have continued to improve. Something like that was really surprising to read just because of the prevailing narrative that you hear about biodiversity decline and whatnot. So is there anything you can comment around that?
Yeah, so there is this sort of big picture observation is that biodiversity has actually been increasing in England's rivers over the last 30 years in general. It may have slowed off in the case of the invertebrates, but we haven't gone backwards. That's the important thing. And that increase in richness is significant. It's statistically significant. We've moved on to touch on benthic diatoms. These are the little algae that stick on stones. They're also monitored by the Environment Agency and macrophytes as well. Now, although there's less data, intriguingly, biodiversity has increased over time. And fish, although there aren't sadly all that many species in English rivers, their richness or biodiversity has also increased over time. So isn't it amazing to recognize that we have an environment that's actually increasing in biodiversity over the last 30 years? The data is really quite overwhelming. And you start to scratch your head and say, well, why do we have this perception of failure? I call our rivers the greatest British environmental success story since the war. But the perception is different. Now, of course,
Yeah.
a lot of public perception is driven by something that's different, which is pathogen contamination of rivers. This is where you have enteric bacteria and viruses that are present in sewage entering our rivers. And particularly, it's likely that higher loads of these pathogens will enter rivers following storm events and combined sewer overflows. That's not the subject of my research.
Yeah.
But the bottom line is this isn't a big deal really for the wildlife because we've not seen its impact in our research.
Yes, and combined sewer overflows have been an enormous issue in the media, and people are generally quite upset by hearing about that. Has there been an increase in recent years to these kinds of events? Or is this something that's a bit of a backdrop that's been happening for some time?
It's difficult to answer your question, Chris, because we haven't monitored the number of combined sewer overflows until very recently. Essentially, our system was designed to do this. So the way our sewerage system works is what you have is big urban areas and a lot of impermeable. And when it rains, and particularly a lot of rain, that water has got to go somewhere. What town planners decided to do was to take advantage of the sewer network and redirect it. There are two problems there. One is if rainfall events become heavier and more intense, you've got more of a water shifting problem. The other is obviously urban sprawl, but also, which people perhaps don't acknowledge, is lots of people have concreted over their front gardens to park their car on it. So you end up with even more impervious surfaces. So this, I guess in the end, overwhelms the design for which the sewage works was originally made. So what the sewage works tend to have, particularly large urban works, is called storm overflow tanks. And that's where they sequester excess water in the drains into a tank. And in theory, they can hold on to that and then treat it once the storm has gone. But those are clearly being overtopped. If you said, is this getting worse? It's really difficult to answer that. It's probable the answer is no, it's always been with us, but we've only just started measuring and being concerned about it.
Yeah, because I mean, even just the fact it's not a particularly pleasant thought in terms of what's happening, but also sort of in the knowledge of what we assume, again, going back to prospective risk assessment about the chemicals that we use and their pathways to the environment, I guess these sorts of events are overriding some of our assumptions there. So it's natural, I think, for people to be concerned.
I think the one thing you need to bear in mind, let's be pragmatic, Chris, is that these events tend to happen when there's a lot of flow in the river at the same time. What that means is you then have an increase of possibly an order of magnitude or more of dilution capacity in the river. So the net outcome may be nowhere near as bad as you might presume for the river as a whole. That doesn't mean that the immediate receiving water, if we imagine it's a tiny stream, wouldn't actually see an increase in concentrations. But probably the biggest issue is more the pathogens again, because if we remove, let's say, 99% of pathogens in wastewater, and then we now don't remove them, that's a twofold increase in load. If we say remove 80% of a chemical, and then we go down to not removing any, then that's a fivefold increase. But if dilution has gone up, say, 30-fold, you can see that the net impact may not be quite as bad as you think. Having said that, there are issues which, to me, are still unresolved on what is the chemical content of those extraordinary runoff events. My concern is particularly around metals now. It could be that there's quite a lot of metals build up in urban surfaces and they're washed off in these storm events. So you have a transient shock load. entering the
Yes.
rivers. Interestingly, in that paper looking at the relevance of factors for macroinvertebrate richness, urban areas in the upstream land cover are highly negative for richness.
Mm.
Now, you might have said, oh, well, that's just sewage works or poor habitat. And no, the statistical model is saying it's not those
Mm.
necessarily, it's something else.
Hmm.
So there may be an issue with shock loading, temporary shock loading of things like highly toxic metals from the runoff.
Right, I see. No, that's interesting. And before we go back onto that study, you mentioned there about the composition of these releases. Do you think that they could also contain some of the more hydrophobic
Yeah.
gases that would normally be removed with sludge?
Yeah. So you could imagine a lot of the organic combustion products that
Mm.
we generate from transport in urban areas could also be sitting around, mobilized, attached to
Mm.
dust. So they may be part of a toxic package associated with extreme runoff events.
Hmm. Hmm.
Um, there again, the dilution effect could help much of
Hmm.
the river. So it may be a
Yes,
local hit,
yes,
but it's
yes.
something that we should still explore.
Going back to your study, it was very interesting to read the analysis and, like you say, the elegance of trying to tease insights from a very large, noisy data set, which is where I think a lot of, as you said, treasure is hidden in terms of insights that you can't normally get from a laboratory test or any other means. So that's really nice. I noticed that you looked at the latitudinal differences because there were
Yeah.
sort of issues related to metals in the north of England, and that you also didn't notice a stronger signal with connection to wastewater, which again I think links to what you've been saying about questioning the impact of chemicals or what we call micropollutants on this biodiversity. And I was also wondering, because we've heard about poultry farms quite a bit and the runoff from poultry farms, I imagine looking at ammonia and things like that would be what would be picking up those kinds of issues.
It could. So I suppose that the strength of the study we did was that it was an all England study.
Mm.
That means you've got a huge data set. When you zero into a catchment, you have a lot less data, so you have slightly less confidence statistically.
Mm.
We've also been looking a little bit at regions, as you've pointed out. So we found that northern England was the only part of, sort of main England that we could recognize a decline in invertebrate richness, which seemed odd, I suppose, if you think of the conventional wisdom, because northern England is almost like the most beautiful part with the least human population, the least wastewater. You say, well, that should be one place that's fine.
Mm.
Actually, it wasn't. We looked again at northern England and we found it was one area where zinc concentrations are actually rising to toxic levels.
Mm.
And it was a bit of a head scratcher as to why zinc should be rising, because my vision of things like zinc is it's a lot of it's a legacy pollutant.
Mm.
But what we know is that northern England is one of the sites in the UK with legacy zinc mining, quite a lot of it.
Mm-hmm.
So what we suspect is that there's a lot of historic mine spoil, mine waste, or even, old caverns of mines that can be mobilized by water. So you might ask, well, why is it happening more now? One theory is that northern England, with climate change over the last 10, 15 years, has had more serious, intense rain events than anywhere else in the country. So that could be something that is remobilizing historic zinc in a way that perhaps hadn't happened before.
Mm. Yeah, and I suppose in a way, there's not a lot we can we can do about that to an
Well,
extent.
the first thing is, I think, Chris, is decide, investigate what is the principal problem first.
Yeah.
Let's not futter around going in circles chasing one new microorganic pollutant after another forever and a day. Let's
Mm.
find out what matters to wildlife. Then the second question is, in a way, what do we do about it? If we are serious about helping wildlife, we need to adopt a different approach from what we do now and basically ask wildlife to tell us what are the most significant problems holding them back.
Mm.
That's the real attraction of these methods.
Yes. I suppose that there's a challenge in terms of looking to identify a particular compound of concern without looking for it directly. And those monitoring requirements are very data intensive.
Yes, yes, you're right. The foundation of the approach that we have employed and would want to employ again in the future is the existence of monitoring. So we need the UK government and the Environment Agency to continue monitoring in as broader locations as possible, with as much wildlife as possible, and as many different factors and different chemicals as possible.
Mm.
I think the thing with monitoring is it's kind of been seen as either a sort of distress activity you grudgingly do for your legal requirements, and a sort of rather dull, uninteresting activity. If you were a research council and you said, can you fund me to do routine monitoring for a few decades using methods that we've used for the last 20 years, you'd be sent packing. I don't know what problem or solution it will do, but will you fund me? It wouldn't be a problem, it'd be a
Yeah.
cinch. So it's an absolute Cinderella, but it is the most valuable tool that we possess to unlock our understanding of wildlife and the environment and how we influence it.
Hmm.
And I think scientists arguably have neglected it. If you look at the range of grant applications and so on, there's very little that are utilizing these wonderful data resources.
Yes. Yes. And are you able to comment on regionally whether it's a steady trend or a declining trend in the amount of monitoring that we're doing, or are we looking?
So, in terms of monitoring effort, it's gone down. The
Mm.
Environment Agency budget has decreased almost 50% in a decade, and
Mm.
monitoring effort has gone down. The Environment Agency is constantly trying to cut the cloth to fit its purse.
Yes.
When I've sometimes gone to DEFRA and say, look, why don't you put more effort into monitoring? They say, well, nobody really talks about it or uses it very much. Nobody likes to be committed to long-term funding.
Mm.
It's a sort of wham
Yeah.
bam, get something, move on.
Yes.
But that is not going to resolve these profound environmental questions. But
Yes.
monitoring can.
Yes. Well, a theme that I keep seeing in my discussions on various areas, but I do think it is a societal problem, is something around responsibility and how we don't sort of value it as much anymore. So something like this is probably a relatively thankless task. As you say, this data would be collected and put somewhere. It wouldn't be able to go on social media with a big kind of banner announcement. And as a result, it's just not going to be valued in the same way.
But it really is, each year of solid monitoring data of all integrated factors is an amazing, valuable block of gold.
Mm.
Useful today will be useful tomorrow.
Mm.
But what we tend to do in science, really, as we just discussed, is what we call reactive, and we follow the bandwagon, and we basically
Yeah.
repeat the same experiments we've always done. Nobody knows if wildlife are better or worse off, and everyone kind of pats each other on the back, and it's just so frustrating that we don't really get to the heart of what is really driving wildlife and what we should do about it. I mean, one thing you might want to go on to, Chris, is the
Yeah.
way the Water Framework Directive and ecological status has muddied the waters in the sort of
Right.
debate about rivers.
Yeah, please. So I will sort of say that my expertise lies more in the REACH and CLP areas of chemical hazard and risk assessment, but I'd love to hear more about the Water Framework Directive.
Yeah, well, you just have to open a newspaper to read about their Save Britain's Rivers campaign. Any newspaper, they've all got these campaigns.
Yes.
And you can switch on the television, listen to all sorts of personalities telling us how bad rivers are. And they always bookend it with the Water Framework Directive ecological status saying only about 14 or 16% of water bodies achieve good ecological status. And you think, oh my God, that sounds terrible. But almost nobody knows how the Water Framework Directive works and what ecological status is actually referring to. It's become a sort of gold standard, of course, for also charities to use to explain to their members how poor rivers are. And, government and DEFRA are sort of flayed with this figure all the time.
Yes.
So we've done research into how the Water Framework Directive works, and to understand that, you've got to understand what I suppose the founding fathers' aspirations were.
Mm-hmm.
And what was viewed was that there were only really three major problems in the aquatic environment. That was organic pollution, nutrient pollution, meaning phosphate, and habitat degradation. So what they did is they said, we'll do a two-tier approach. We'll measure the chemicals and we'll measure indicator species to see if they can signal whether those effects are happening, the damaging, the presumed effects are happening. So what was used was the macroinvertebrates were used to reveal whether there was poor organic water quality. Diatoms and macrophytes were used, but in a rather specialized way. So what they did is regulators have to see whether species sensitive to phosphate are present or absent. This is different from an unbiased assessment of the biodiversity. It's almost using the wildlife as a chemical analytical proxy. And the third thing was fish assemblage. So you ended up with some computer models which, based on very historic assumptions, predicted the species that should be found in any one place and the numbers. And if you didn't find them or didn't find the numbers, there was something going wrong, and that could almost only mean that there was something wrong with the habitat or connectivity. So essentially we've been recording our results for, it's called cycles since 2009. And what happens is if you fail on any one of those indicators and a series of chemicals, you can't achieve good ecological status. So if I put it another way, imagine your child in their GCSEs had got 10 A's and 1 D. If that was Water Framework Directive, that means they'd effectively failed. Not good status child, sorry.
Yeah,
You're in a bad position. So this is called one out, all out, this philosophy.
Right. Yeah.
So essentially, it's a rather perverse view of the environment that there are only mainly three stressors, and that success is not monitored, not really recorded. So essentially, you had an environment that was improving constantly on biodiversity, but you had the water framework metrics saying there are no improvements. So if you follow the rigmarole, it actually forces the government to constantly spend money on more phosphate removal because that's the one you routinely fail. So that means you and I and all the ratepayers have to dig into our pockets and pay more for water. And this requires a sort of chemical removal of phosphate in sewage works, which there now is proposed to extend to small sewage works. This is billions in capital and operating costs. It
Right.
means more sludge. But tell me, Chris, is phosphate the main thing holding back biodiversity?
Apparently not.
No one's really asked.
Yeah.
No
So we're
one's
into
really asked.
diminishing returns.
So what you could be doing is forcing the ratepayer to spend huge sacks of money on something that may not be the most important thing for biodiversity.
Mm-hmm.
So if you turn the question on its head and say, look, what we should be trying to do is think of biodiversity as the key standard for rivers and have increasing biodiversity relative to the location as the target, what should we do?
Mm-hmm.
Then you come up with a completely different approach,
Yes.
which is outcome focused. This is kind of my whole beef with the way we consider chemicals and so on in the environment, is
Yes.
that we spend far too much time pondering risks and not enough time looking at outcomes for wildlife.
Yes. Interesting example, and I seem to recall that there were some rule changes in the Water Framework Directive recently, which also knocked everyone down a peg in terms of their
Yeah.
status, which has, as you said, given everybody a nice sort of fact-based statement to complain about the state of water bodies. It reminds me a little bit of the session which, when I first came across you, I was in the audience, a session in CTAC Europe meeting in Nantes in 2016, which was looking at how we're going about chemical risk assessments for the aquatic environment. Are we going about it the wrong way? And that was a really thought-provoking session with presentations from various people, including John Sumpter and Peter von der Oe from the German Environment
Uber.
Agency.
Yeah.
Yes, from the UBA. And I seem to recall that they had together some monitoring data that they were comparing to these risk characterization ratios that get derived as part of our standard regulatory frameworks, and they were presenting that there was a big, potential issue there because there were these exceedances of the risk characterization ratios, and then you were presenting some information on biodiversity, which seemed to point in the other direction. And putting things together that way, I think, got a lot of people thinking about the direction of travel. But I think that, since then, we're nearly 10 years since that session, we've had the announcement of the European Chemical Strategy for Sustainability with a whole raft of new policies coming through. In recent years, the pendulum seems to be swinging back the other way, potentially due to geopolitical reasons. But one of the key pillars of the chemical strategy was this concept of a mixture assessment factor, which was essentially addressing the concern that there were these exceedances of RCRs and that no organism is exposed to one single chemical. Therefore, we need to do something to aggregate these RCRs to try to account for the fact that chemicals are exposed as mixtures. And that's become a big political football as part of these measures. But I guess, based on what you've already said, you would have questioned that idea from the outset.
Yeah, I mean, where do we go, Chris?
Mm,
Okay, we're getting more and more concerned about chemicals, but the wildlife, in terms of biodiversity in the river, really has improved despite the mixtures. So yes, really, I can't shift this super tanker. I really
yeah.
can't. And so you get things like all sorts of bioassays perhaps to use to look at sewage effluent. There are other ways of doing risk assessments such as
Mm,
adverse outcome pathways.
yes.
And no one's asking wildlife their opinion.
Uh,
Why are we here? What are we doing it for?
At least with some of those measures, the bioassays, you're trying to look at sort of an aggregate of different things and you're combining fewer things together. I think part of the problem that we have is that societally we developed this risk assessment framework that was based on a predicted environmental concentration and a predicted no effect concentration. We applied reason and logic to make decisions about what we thought would be considered safe. And then we were unable to reason and logic our way out of the fact that there is co-exposure to different chemicals. Whilst it may be unnecessary from a policy point of view for the protection of wildlife, it's been difficult for people to argue against it.
The thing is, I'm not against the risk assessment approach in general. It is valuable in terms of prospective risk assessment. This is before a chemical comes on the market. But in terms of our understanding of risk for chemicals now and mixtures, it's all conjecture and informed speculation with a disinterest in wildlife outcomes. You know, we have been using a vast range of chemicals in our daily lives for 30 or 40 years, the variety. And fish and invertebrates have been swimming in that soup, and their abundance and richness has generally increased. Yeah, I think there's a message there, but no one's, why do we not connect to wildlife? Why do we not why do we not ask them, where is the threat for you? Where are the problems? We are totally divorced from them.
Yes. Well, I've had other guests on the podcast. So Peter Fisk was one of them, who was reflecting on the sort of past 40 years of regulatory developments in Europe. And one thing that he was commenting on was the fact that now we have regulations like REACH, where we have to investigate each chemical individually in quite a lot of detail. That has, in a way, diluted our focus to find those problems that are of greatest concern, and it's also put a dampener on things like innovation, because it is so costly and risky to try and develop new chemicals for the market. So maybe it is, as you've said, there's this feeding frenzy every time there's a new issue that comes about. Maybe another problem is that we have also diluted our ability to focus on real challenges.
Yeah, I think it's just a chemical risk obsession that has essentially brought this area of science, to my mind, to a halt. I really, do I have a purpose? Do I have a purpose? Do I have a reason for doing the research I do? I'm not fascinated by chemicals for their own reason. I want to go out into the environment and ask myself, what do I need to do to make it better for wildlife? What should I be doing? How do I know what will affect wildlife? Where are the things that are the greatest stressors? Now, this whole regulatory risk merry-go-round does not address that question, and indeed remains in this conjectural bubble. It's just extraordinary. And it could be that wildlife is crying out to carry out some basic changes. Maybe it means in some way bearing down on reducing things like zinc and copper getting into the environment, and we'll get some benefits. At the moment, we spend many millions on research. We spend billions on things like trying to comply with the Water Framework Directive. But to what effect?
Yes.
One thing that strikes me, Chris, is that when I was developing my career, which essentially came to following and tracking and understanding risks from different organic pollutants, in the old department I worked in, I bumped into these old guys who worked on metals. And they were old. And we saw them as a sort of outdated old guard. We rather felt sorry for them, a bit like beached whales. And really, they should get where all the fun and excitement was, which is whatever the latest endocrine disruptor, antibiotic was. Much more important, much more relevant. But that was wrong. That was wrong. It could be that the oldest, most boring chemical pollutants that all of us couldn't give a damn about are the ones that are 90% of the problem.
I mean, it's fascinating, and things often do flow in cycles like that, don't they? That we come to these realizations. But I guess also perhaps a counter argument is that, nobody would want to be accused of being complacent about about the environment or about the impact that we might be having? And is there a chance that if we took our eye off chemicals that we might miss something? And do you have any thoughts on how we might mitigate against that kind of a risk?
Well, I can't defend my position without chemicals that I may appear to dismiss not being monitored, so I don't have the data to use statistical methods to see how closely they align with outcomes for wildlife. So I would strongly want more measurement of more organic chemicals of concern in more places, and then we can put them in the models. I think the thing that most of these organics that we worry about will be connected with wastewater discharge. And that proved to be important, but not as important as the others. So it puts it, to me, somewhat in a box, as there will be issues.
Yes.
So I'll try and give you an analogy. Imagine you're sort of in a Bond movie, and you and your colleagues have been put into this room, and you're sitting around the conference table, and ants are released. And they start to bite you, and that's quite itchy. It's really quite annoying. Then we get mosquitoes. That's also annoying, and you're slapping yourself. And then the evil secret crime boss starts to put poison gas into the room that will asphyxiate you. Now tell me, Chris, which of those three things would you like me to deal with first?
Yeah, I do really dislike mosquitoes, but I think the poison gas. Yeah, no, you're right. Well, I mean, I hope that there's something that can be done to address this issue, get people thinking about focusing on more on the right issues. I don't feel that this is quite a popular view, let's say, and that people are still quite preoccupied with chemicals and their hazards and estimating their exposure in the environment. In fact, I would say that things almost seem to be going in the opposite direction, in that we're looking at chemicals from an intrinsic property point of view and no longer looking for where we expect them to be or how much exposure we expect there to be to these chemicals.
Well, the consequences, basically. What are the consequences?
Yes.
Yeah, I'm probably the most annoying person in sort of environmental science for chemicals.
Well known, perhaps. No, but it's. I think if we all, adopted groupthink, then we would probably leave ourselves exposed to quite some blind spots, wouldn't we? So
that's the danger. If you're trying to advise a young scientist on their career, you would say, move to the zeitgeist, the new chemical on the block, get in there quick, publish one or two papers, you will get cited, you will get noted, you will actually get pat on the back. The journal editors will love you, your peers will be impressed, the regulators and everyone will be happy with you, and when the next chemical comes up, do the same. If I was to say, no, actually don't follow the crowd, do totally different type of research to find out what the real problems are, which may end up coming from very boring chemicals that no one can be bothered to listen to, you'd have to say that's probably not very good career advice, would you? The problem perpetuates itself, Chris. I keep having, review grant proposals, which are essentially the same as what I read 20 or 30 years ago. I know it won't have any benefit to the environment, but my fellow referees will all think it's lovely and it's what they want to see. And we're wasting time.
yes.
We're wasting time.
Yes.
Would you change what you're doing? Would you change the way you do your science?
That is the ultimate question, isn't it?
Well, yeah, I think it does mean asking questions and making yourself unpopular. But you only have a loyalty to the data. That's where your loyalty lies. In science, you're kind of like a warrior monk. You have to study a lot. You will be challenged constantly. And in a way, it's almost nicer to be with the crowd. But it depends what you're here for. As I said to you before, what's my purpose? Why should I be funded by public money, private money,
Yes.
if I'm not
Yeah.
making the environment a better place?
I think that's a really nice place for us to conclude this discussion. I was going to go on to ask you about how the media and social media have sort of transformed this arena for better or for worse, but perhaps people can guess what the answer to that question might be.
Yes, I remember there's a lovely saying my old father had, which was, don't let facts get in the way of a good story.
Yeah. So, but credit to you, because I did notice you were on a panel with Magazine that had quite a high production value. I thought probably more so than this this podcast, but it takes all different ways of engaging with people, and I do think that there is also a need to try and educate the public a lot more about chemicals, because for a long time they've been completely in the dark about what we've been doing with chemicals that's brought all the benefits to human well-being and whatnot, and
Yes.
starting to learn now about that reality, and that they're quite horrified, I think, with what they hear.
Yes, there's a lot of naivety. In a way, I don't think scientists have helped. They've infantilized the audience so that everything appears to be a problem. My new chemical is obviously far more dangerous than yours or yesterday's chemical. The problems are probably enormous. If you reflect on England, we're amongst the most densely populated countries, developed Western countries, certainly in Europe. What that means is that our rivers are under more pressure from agriculture or wastewater than almost many in Europe or the world, and our biodiversity is increasing in those rivers. Just think about that. That's an achievement. I don't think it's an accident, Chris.
Yeah.
I think that our metals, which I'm fingering as a major culprit, our metal discharge has gone down considerably. And that's, I think, probably largely driven a lot of this improvement. Also, the Urban Wastewater Directive improved biological treatment at many works. That means lower organic matter and lower ammonia, which is also a real benefit.
Yes. Yeah. It's good to focus on some of these positives when, with all the prevailing messaging that we hear.
I like to think people would be encouraged by the fact that we have improved our natural environment from the better, but you kind of feel nobody wants to listen, at least not in the media. There's the old story, if it bleeds, it leads. Yeah.
Well, let's hope we can get some of this message out there and get some of our colleagues to start thinking to do the same.
Good. Well, thanks very much, Chris. I very much enjoyed our chat.
Yeah, I have too. Thank you so much, Andrew. It's been absolutely fantastic. And apologies to, I think we could have talked for a lot longer, and maybe we will again. So what I normally do is I normally ask my guests, what's a big goal that they're working towards right now? Perhaps we have to skip that one. The other one is, what is some advice that you'd give to somebody starting out in their career? And you've already given out some really good advice, but I wanted to also mention that you did write a book with John Sumpter, How to Be a Better Scientist, and yeah, it was a very nice read, so I recommend that to anybody who's looking to remind themselves, or perhaps they're just starting out in their careers.
Yeah. I think if I was going to guide people, is I think of what are the big questions. Don't be afraid to ask them. People always say stupid questions are often the best one. I think that's certainly true in science. And the other phrase, which I think is the motto of the Royal Society, which is take no man's word for it. Go to the data.
Oh, that's really good advice. Okay. Thank you very much, Andrew. And thanks to everyone who's been listening. Your time is really precious, and so I'm really grateful you've spent it with us. If you've enjoyed this, please, again, tell your colleagues and friends about the Chemical Journeys podcast, and I look forward to speaking to you next time. Thanks again, Andrew.
Thank you.